first. So I have just one pen drive. Let me just show you the pen drive first and what I have done with this. Devices there. So you can see here, I have got one pen drive here. Okay. Pen drive you can see.
Yes, sir.
Visible. In this pen drive, what I have done, I have partitioned this pen into two components. Okay. So this pen drive is partitioned like any hard disk we partition. So I have partitioned this pen drive. Now let me put this pen drive. Sorry. Okay. So now you can see my Windows screen, Windows machine you can see, and here you can see two USB H, USB 2H and USB 1I. Two drives you can see. One drive is totally blank. You can see this one. And the other one is having certain files and folders, just demonstration purpose I have kept something. If you see the file structure, here we have, so this is basically FAT32. This I drive is FAT32 and it doesn't have any information. This is FAT61, 16. You can see here, this is FAT. Basically, it is FAT16 only. Okay. So I have two FAT16, two drives. I have just partitioned this whole pen drive into two components. One is the FAT16, the other one is FAT32. Is it okay?
Yes, sir.
How to do it, you know?
Yes, sir.
To computer management,
Yes,
drive
sir.
management basically in Windows, and you can partition them. Those who do not know, you can go to drive management. I think from here we can go drive management. So this is what I had on Windows PC. This is just for demonstration, nothing very say, you can say specific. So you can see here. So from here I have partitioned, I have divided them into two components. So this one, removable media, I have partitioned them into two ones. So both are primary partition, extended partition. Now let us come to this Kali part. So in Kali, now I'm coming to Kali. So in Kali, if I use to command, I can see. So if fdisk, if you give sorry. So now I have to accept this one in Windows. Devices, USB flash drive. So those two flash drives are here. So now we have USB 1, USB 2, and then you can just issue this fdisk -L. Now you can see, so this is my hard drive. Sorry, this is the hard drive. This one is the hard drive. So it's VBox hard drive. And here I have just around, I think, 50 GB of space. So 51.8 GB of space on the hard drive. So in VirtualBox basically. And we have three partitions: Linux extended and Linux swap. So this is SDB 1, 2, and 5. And then this is my pen drive, 3.8 GB of pen drive. And it has got two partitions, you can see, /dev/sdb1/dev/sdb2. And you can see the partition, the sectors from where this real partition or real data starts is from 128 in partition 1, and it ended at this one. This is the end partition, and total number of sectors in the first partition is this one, which is having FAT16 as file system. In other case, this total size of the disk, the second partition is 2 GB. That's a FAT32 file system. This sector starts from the sector number in this to this is basically part of this. As I told that in LBA, because you can see here, this is LBA. So in LBA, we have already discussed this one. In LBA, we have from start to end, we have the sector numbers. So sector number starts from 0 and it goes into the end one, which is basically 7972991. So this is the end sector and starting sector is 0. So there are total this many sectors. Good. It's so far so good.
Yes, sir.
Clear to everyone?
Yes, sir.
Now let's see the statistics of say device 1. That means this FAT16 drive. So if we click, if you issue this command sudo, why I'm giving sudo? Because you can see that I am using a different user ID. So that's why I'm giving sudo. If you use Kali, then probably you do not need to give this sudo command also. You can run it as it is. So sudo fstat -f fat and then /dev/sdb1. So if I issue this, this is what I'm getting.
Excuse me, sir.
So, yes, someone wants to tell something?
Yes, sir. Sir, I am asking
Bolo.
that in 0 to 128 sector, so what the
Hmm.
data is stored there?
Let's see. Let's see.
Okay, sir.
Okay.
Okay, sir.
Let's see. So here, so what we discussed last day also, and everything else. So now you can see if I issue this command for the first drive, that is SDB1, you can see the file system information it is showing. So in file system, we have file system type, which is FAT16, OEM name. OEM name is normally the operating system which is used to say format or partition this drive. Format the drive or the operating system which created this file system. Normally for Windows 7 and onward, it gives MS-DOS 5.0. So with different, these are Microsoft operating system, but Microsoft's different operating system will give you different names, and that you can try. Then the volume ID, and then volume level. So boot sector, there is no name for this boot sector. And the total volume name, as you could have seen that it was USB 2. That user name, what the user defined name, what I had given was USB 2 and file system type is 16. Now here you can see sectors before the file system. So the initial some part of this whole disk is basically reserved. So actually 128 onward only the sector information has been started. Everything before, so sector number 0 to 127 is not used at all. So that's some other purpose, and that's where say some user may use that space, because that's where we are talking about. That's why we are talking about the file system types, and then last day we talked about the direct access. So that means there are two ways you can say analyze a file, analyze a disk. One is the raw disk. So you can start from reading from sector 0 to end without considering any file system. So you do a physical analysis, exactly what is there. So if you have a concrete information about the file system and everything else, then you can start with sector 0, 1, 2, 3, 4, and you can see what else, whatever is there in sector, in every sector. But if you do some analysis related to the file system, then your structure will be different. So the file system really starts here from 128. And in the first part of this file system, you can see that the 0th one. So total range is 0 to this one. 0 to 5, that means after 128, next one, that means 128 number. So since it starts from 0, so 0 to 127 is reserved. It is before the file system. So 128th is basically from 128th to next 5. So 128, 129, 130, 131, 132. These are basically reserved for the boot sectors. Reserved by the file system. Initial system. So file system does not touch on that. Boot sector is in 0th, that means 128th. And then we have two FAT structures. So if you see in the file system exactly what happens, let me just draw. So let me open a paint window, and then you can see that, sorry, I'm really very bad with this mouse. So up to 127, it was totally reserved by the system. Do not know exactly what happened. Next one, that is 121, is the boot sector, as you can see here. And again, next 5 are reserved. So is boot sector, 1, 2, 3, 4. We do not on 5, so 0 to 5, so 6 sectors. So 1, 2, 3, 4, 5. We do not know, these are reserved. So up to this 5, so next 5, that means up to 1, 128, 29, 30, 128, 29, 30, 31, 32. So this is 132. So up to 130, in fact, all these sectors, these 6 sectors, only one sector, that is 0th sector, is containing the boot information. Rest are blank. So again, rest are the places where a user can hide his or her data. Then next is, you can see we have FAT 0 and FAT 1. So now what is FAT basically? So starting from this place to, we have total up to 242. So up to 242. So this is say 242. So up to this we have FAT 0. I will come to that, what is there in FAT 0. So this is FAT 0. And next is FAT 1. This is FAT 1. So starting from 242 to, so 243 to 479. So say if this is 479. So up to this we have FAT information. Then next, following 479 means 482, this last. So this to last, this is the data area, basically the content. Okay, so this is the total structure what we can get from this information. So if you see this information, 0 to 5, that means first 6 were reserved, out of which the 0th one was the boot sector. Then 6 to 242 was our FAT 0. So this was our FAT 0, this is our FAT 1, and then we have the content. Now inside that content, again, we have our basically the data area. What is data area is what we studied last year as the name content. So in this content, again, out of those total content, we have around 480 to 511. So if this is 480 to next 511, this is a directory, and this is called as root directory in Windows. So up to 511. So this is the root directory from where every other directories are created. Am I clear? What is
Yes,
root
sir.
directory here? In fact, in Windows, we do not have the word, we frequently use it. We do not say root directory, but say C drive. So C drive के अंदर में बहुत सारे folders होते हैं और files होते हैं.
Yes, sir.
So C is basically our root directory. So C represents the root directory. In Linux, we give a slash, and that is considered as root directory. So inside that directory, we will write some information. We will be coming to that. And then it's more area. So you have a cluster area. And as we talked last day also, कि हमारा hard disk तो sectors में divided है. But when we talk about the data, जब operating system, जब एक file system बनाता है, so whether it is going to really address one sector or sometimes it can make a cluster. Okay, एक file को जब हम place information देंगे, I will give basically a cluster to a file. And one cluster may contain several sectors. So your cluster area, it starts from this. And you can see here the cluster information is this. One cluster is of size this much. So if you divide it by 5, कितना होगा? कैलकुलेटर 32768 divided by 512. So 64. In fact, 64 clusters together gives one cluster. So यहाँ से जो ये total cluster area, total file area, content area है, ये this one. Let me just draw this one. So this area. This area, let's say if this is so big, so you can see that this is one sector, second sector, third sector. So this is 64 sector. So this together will give one cluster. Am I clear?
Yes, sir.
Yes, sir.
So when a file is being created, a file will get at one go, it will get 64 sectors together. एक साथ 64 together sectors उसको मिलेंगे, जिसको वो cluster बोलता है. And you can see there in this case, the minimum space which will be allocated to one file will be this much, 32768. This is the minimum space given to one file, because एक cluster तो at least देंगे, और अगर एक cluster देंगे, so this will be the size for that particular file. ले जाइए. Got it?
Yes.
Yes, sir.
अब रहा क्वेश्चन कि किस फाइल को कौन सा क्लस्टर दिया हूं. So say clusters can also be numbered in the same way. Now you can say, sir, this can be cluster number 0. But in fact, you will be surprised to know that the first cluster is basically numbered as 2. FAT file system में जो पहला cluster होता है, that starts with 2. So second is the first cluster. Number 2 is the first cluster. Right? समझा पा रहे हैं तुमको? बोल, मैंने, are you getting this really what I'm trying to say?
Yes, sir.
Yes, sir.
अब ये क्वेश्चन रहा कि अगर हम से एक फाइल को एक क्लस्टर दे रहे हैं, so where that information will be stored. Say I have created a file which is F1. So I have created a file F1, and say file F1 is stored in cluster 2. Then where this information has to be written somewhere, कि फाइल F1 cluster 2 में stored हुआ है, कहीं तो लिखना होगा ना.
Yes,
जी,
sir.
सर.
तो कैसे पता चलेगा कि फाइल 2 कहाँ पर स्टोर हुआ? And that's what we will write in fact information in this fact area. अगर अब कुछ चीजें समझ में लॉजिकली आई हो देखने में. So whenever we will create a file, what we will be doing basically, we will be creating an information in this fat area. Okay, in this fat area I have created कि F1 create हुआ. उसके लिए एक data area देंगे. So one cluster I will assign, and then I say कि okay, in this fat area file F1 contains a cluster 2. अब अगर मान लो कि वो फाइल बड़ा है, एक क्लस्टर में नहीं आया, so then probably I have to give another cluster also. That cluster can be consecutive place or somewhere else also. It doesn't matter. In a linked fashion, we can give it.
Yes, sir.
So that's how we. So हम लोग उस information को ऐसे रखते हैं. यहाँ पे वो दिया हुआ है, देखो. So पहला फाइल तुम ध्यान दिए होगे तो उस फोल्डर में मेरे कुछ फाइल्स थे एक पर्टिकुलर ड्राइव पे. So देखो जो पहला फाइल है वो एक 64 एक साइड सेक्टर्स दिए गए उसको. Now you can understand why 64 clusters have sectors have been given to that file, because one file will be given will be given one cluster. और वो cluster कहाँ से कहाँ तक जा रहा है? That first file is being stored in the area or sector number 512 to 570. The second file is stored in 576 to 639. The third one is stored in 640 to 703. Because I just formatted, why this one? Because they are going consecutively, and now you can understand easily that what is being done is कि वो चूंकि consecutive create किया हूँ, format करके ही इसको consecutively फाइल मैंने लिखना शुरू किया. So जो फाइल पहला बना, that file was given the first block, that is means 512, and that was the first, I think, area which was free here. So you can see the cluster area started at 512. So पहला cluster पहले फाइल को दिया गया. Then the second cluster was given to second file. Third cluster was given to third file, and the files were very small. In fact, कुछ भी नहीं लिखा है, मैंने just new से create कर दिया है कुछ फाइल. I will just show you. Then you can see the last one. And because I told that this file, the whole area was blank and consecutively इनको store किया गया, तो जो last file है देखो, उसके लिए इतने sectors दिए गए हैं. That file, because that file was a big one, so that file required basically almost 188 MB का फाइल था. So 188 MB के लिए कितना चाहिए? 188 MB मतलब कितना हो गया? 188 into 1024 into 1024 divided by cluster size कितना है? 512 into 64. Oh, somewhere I'm making a mistake. 188 से 181 या 88 था, 88 ही लेते हैं मान लो. कितना होगा? 188 into 1024 MB का अगर है तो, और फिर 1024, so इतना आया डिवाइडेड बाई 512, इतना हुआ डिवाइडेड बाई 64. सो नहीं, कहीं गलती कर रहा हूँ मैं. हाँ, yes, it's good. So it's coming at around 385,024, जो कि exactly number मैं नहीं लिया हूँ. So इतने sectors उसको चाहिए almost, which is very close to the number which is shown here, and इसीलिए इतना यहाँ से इस sector से लेके इस sector तक हो गया है. As I was not very sure कि 188 MB का है, but that you can do. And at last EOF देख सकते हो, उसका मतलब है कि ये एक सिर्फ यहाँ से यहाँ तक गया है, उसके बाद एंड ऑफ फाइल मार्कर है. दैट मीन्स उसके बाद इतना में ये खत्म हो गया है और ये इतना में खत्म हुआ है. And that's what will be stored in this FAT system. So FAT में actually जो arrange होता है वो ऐसे arrange होता है. So something like this. ये ऐसे स्टोर होता है फैट में. ये फैट है, फैट 0. कि ये कॉन्जिक्यूटिव नंबर्स होंगे एरे टाइप का, 0 1 2 3 4 5 ऐसे जाएगा. अब मान लो कि यहाँ जैसे कहाँ से शुरू हो रहा था, मानने की जरूरत नहीं, 5 से शुरू हो रहा है, तो ये फैट जो है शुरू करेगा से मान लो 512 से. जस्ट ड्रॉ द रियल पिक्चर. सो ये फैट है. ओके, सो will start with 512 क्लस्टर जहां से शुरू हो रहा है, and this will end with, पहला फैट कहां से जा रहा है? 0 से तक था. हेलो हेलो, हाँ, हाँ, ये कहाँ से जाएगा जी? फैट 0 6 to 242. 6 to 242. Starts at 0. तो टोटल क्लस्टर्स कितने हैं? टोटल सॉरी सेक्टर्स into this is the total data area. So ये डेटा एरिया है इतने सारे. So इतना एरिया है डेटा एरिया. This to this. Okay. So what my cluster information? Actually, cluster information starts out the data exact data area starts from 512. So what we can do here, like 512 to last जो भी number यहाँ पे आए, that now say first 5 but stored in. So पहले का जब वो बनेगा तो ऐसे बनेगा. इसमें 3 इंफॉर्मेशन होंगे इस फैट में, फैट 0 में. फैट 0 में ऐसे इंफॉर्मेशन स्टोर. ये फाइल नेम होगा यहाँ पे, नेम. Then the starting address. So starting address is starting sector number is 512, and then size. So size here is very small size के फाइल थे, almost 0 size ही होगा उसका. अगर देखोगे तो हो सकता है कि 1 MB या सॉरी 1 KB या 2 KB का होगा. मान लो कि ये 2 KB का भी हुआ तो भी ये क्या होगा कि वी नो दैट वन क्लस्टर. सो रियल साइज, इसलिए तुम्हारे दिमाग में ये क्वेश्चन आ रहा होगा कि सर कभी कभी तो हम तो जब फाइल देखते हैं तो हम रियल साइज दिखाता है कि अगर वो 0 बाइट का है तो 0 बाइट ही दिखाता है, 1 बाइट का है तो 1 बाइट ही दिखाता है, हमको तो 64 KB नहीं दिखाता है. होता है ना?
यस सर.
हेलो, हाँ कहाँ है? हाँ अंदर है तो आप घर चले, क्वार्टर में चले जाइए. 304 नंबर क्वार्टर, टाइप 4. हाँ टाइप 4 में 304. ठीक. So that's how this information will be stored, and in this 512 there will be an entry. ये 512 में क्या होगा? ये फाइल यहाँ से ये now you can understand कि 512 हो गया तो ये यहाँ पे इसको मार्क कर गया और यहाँ पे हम EOF लिख देंगे कि इसके बाद इसका कुछ नहीं है. तो 512 से जो शुरू हुआ, जो इसके सीक्वेंस है, उसके बाद इसका और कोई फाइल नहीं है. जैसे ये एक लंबा फाइल था नीचे वाला, तो उसमें जब शुरू होता तो क्या होता है कि 512 नंबर यहाँ आता. सो 512 के बाद से सेक्टर नंबर 513. इसका मतलब है कि ये फाइल अभी कंटिन्यू कर रहा है. अगर मान लो कि यहाँ EOF नहीं लिख के हम यहाँ लिख देते 513, तो दैट मीन्स कि दिस फाइल कंटिन्यूज इन 513. सो ये नेक्स्ट फिर से रीड करेगा फाइल, जब भी रीड राइट कुछ भी होगा तो. फिर अगर यहाँ पे 514 होगा तो इसका मतलब है कि ये फाइल अभी और कंटिन्यू कर रहा है. और मान लो कि 514 पे आने के बाद अब ये खत्म हो गया कोई फाइल, तो यहाँ EOF हो जाएगा. Am I clear? The structure is very simple.
यस सर.
512 से शुरू हुआ, अगर एक ही का है तो EOF हो जाएगा, अगर ज्यादा है तो नेक्स्ट कहाँ पे है, फिर नेक्स्ट कहाँ पे है. और चूंकि इस केस में सीक्वेंशियल है, हर केस में सीक्वेंशियल नहीं भी हो सकता है. हो सकता था कि पहले क्लस्टर के बाद नेक्स्ट क्लस्टर जो इसको मिला होता वो काफी दूर का मिला होता, तो ऐसा भी हो सकता था कि ये 2513 वाला क्लस्टर इसको मिलता या सेक्टर नंबर मिलता, तो ये उस जगह पे जाता और वहां पे अगर EOF मिलता, इसका मतलब है कि बस यहीं पे खत्म हो गया, यानी कि 2 क्लस्टर्स में स्प्रेड है. अगर उसके बाद भी स्प्रेड करना है तो वहां पे नेक्स्ट क्लस्टर का इंफॉर्मेशन होगा और वो मतलब नेक्स्ट सेक्टर नंबर होगा. दिस इज नॉट क्लस्टर नंबर, दिस इज सेक्टर नंबर. सो नेक्स्ट सेक्टर नंबर, लेकिन वो पूरा क्लस्टर उस सेक्टर के साथ ऑटोमेटिक बाइंडेड है. जैसे पॉइंटर में हम पढ़ते हैं ना, लिखते हैं इंट पॉइंटर. सो व्हेन वी राइट इंट पॉइंटर, बेसिकली इट इज डिसाइडेड कि इंट पॉइंटर अगर है तो जितना बाइट इंटीजर लेगा, if we increment it, it will automatically increment it to that size. Similar structure. Is it clear? समझ में आया?
Yes, sir.
Yes,
यस
sir.
सर.
So now यहाँ पे कल हम लोग स्लैक की बात कर रहे थे, तो देखो यहाँ पे चूंकि एक सेक्टर का साइज है 64, और अगर यहाँ पे जो तुम्हारे नंबर ऑफ सेक्टर्स बचते, यहाँ पे रूट डायरेक्टरी के बाद जो बचा है, यानी कि 512 टू द लास्ट नंबर जो भी है, अगर वो डिविजिबल बाय 64 नहीं होता तो क्या होता? थिंक ओवर दिस क्वेश्चन कि जो सेक्टर्स बचे, दैट मीन्स आफ्टर डूइंग ऑल दिस प्री प्रोसेसिंग, पिज्जा, बूट, फैट जीरो, फैट डेटा एरिया, अब जो डेटा एरिया बचा उस डेटा एरिया में कुछ रूट डायरेक्टरी भी आया है, रूट डायरेक्टरी के बाद जो एरिया है वो रियली क्लस्टर के लिए दिया जाएगा। तो जो बचा है, इफ दिस इज नॉट एन क्लस्टर साइज इज 64, सो इट इज डिविजिबल बाय 64, तो हम लोग का लास्ट पोर्शन जो होगा वो एक पूरा क्लस्टर नहीं बनेगा। वी हैव टू लीव इट एज इट इज एंड दैट विल बी आवर स्लैक एरिया।
Yes, sir.
Yes, sir.
Isn't it? So that can be a slack area again. प्लस फाइल के अंदर में स्लैक एरिया होगा, क्योंकि जैसा अभी तुम देखो मैंने जो फाइल बनाए हैं, सो सी दिस फाइल्स, यहाँ अगर फाइल देखो से अनदर वन, इसके अंदर में एक और फोल्डर है, इसका साइज देखो तो सिर्फ 7 KB है। आई थिंक दैट इज विजिबल टू एवरीवन।
Yes, sir.
Yes, sir.
But now you know that although this is of 7 KB, but in reality क्या है, हमको कितना स्पेस मिला हुआ है? 64 into 512 byte, isn't it?
Yes, sir.
एक एक सेक्टर
Yes.
512 बाइट का है और
Yes.
हमको 64 सेक्टर से एक साथ इस फाइल को मिला हुआ है। So we have given or we have allocated a space of कितना, मल्टीप्लाई कर लो अगर, so this number is
32 KB. 32 KB.
512 into 64, so 32 किलोबाइट का है, KB है, whereas we are using 7 KB. So now you can understand 25 KB is left for this particular file, but that space is allocated, right? So that space might be used by someone, जैसे ये 0 KB दिखा रहा है एकदम, लेकिन इसके लिए भी एक स्पेस रिजर्व है और that whole space is again 32 KB. Here you see, say this one, this was a bigger one, that was what I was talking about कि ये total 180 MB का है, sorry 180 MB का बाइट है। अब इतना बाइट को डिवाइड कर ले तो इसके लिए कितना सेक्टर चाहिए, सो दैट यू कैन फाइंड आउट कि इट इज टोटल 189259 डिवाइडेड बाय कितना, अगर हम सेक्टर से ही डिवाइड कर लें, कितने, सॉरी क्लस्टर से, ये सेक्टर से ही डिवाइड कर लें हम, मान लो 512, सो हमको चाहिए थे टोटल 369,648 पॉइंट समथिंग, दैट मीन्स 369,349 आना चाहिए। इतना देखो तो आया है 369,664, कुछ ज्यादा किया है बिकॉज अगेन ऑफ क्लस्टर्स, क्योंकि ये तो मैंने सेक्टर में कंप्यूट किया। अब इस सेक्टर को अगर हम 64 से ये करेंगे तो ये हो सकता है कंप्लीट नंबर नहीं आए। सो अगेन इफ वी डिवाइड इट बाय, देखो एग्जैक्टली जब मैंने डिवाइड किया तो जो नंबर आए थे, नंबर ऑफ सेक्टर्स रिक्वायर्ड वाज 369,648, ठीक है, 369,648 इतने सेक्टर्स इसको चाहिए थे, बट व्हाट वी हैव अलोकेटेड 369,664. So let me just write those numbers. I think on your notebook itself you can also check this. इतना हम लोगों ने दिया, बट इसको जरूरत थी रियलिटी में 369,651. So we have given 12 सेक्टर्स एक्स्ट्रा, हमने इसको 12 सेक्टर एक्स्ट्रा दिया हुआ है। क्यों? क्योंकि इसको अगर हम 64 से डिवाइड करेंगे तो प्रोबेबली जो नंबर आ रहा है वो फ्रैक्शन में आ रहा है और हमको एक नेक्स्ट नंबर में जाना होगा। सो नेक्स्ट नंबर में जब जाएंगे तो उतने सेक्टर्स एक्स्ट्रा हो जा रहे हैं। Okay, so in last file we have 12 sectors extra. 12 sectors extra मतलब 12 into 512. So almost 6 KB of file extra we are giving. Right? So that is
Yes,
again another slide. So I hope you are getting this one.
Yes, sir.
Now So this was for 16. ये information जो था वो FAT 16 का था. Now let's go for FAT 32. So if we go to second one, steps.
सर आपने पेन ड्राइव हटा दिए काली से.
पेन ड्राइव हटा दिया, सॉरी. ये बड़ा प्रॉब्लम है यार वर्चुअल मशीन के साथ. Okay. Now you see that here, so this is from this one, so STB2. So now file system type is FAT32, again OEM, because ये same operating system से और same environment में इसको भी मैंने format किया था. So same number, volume level ID, volume ID same है या different है? देखो volume ID different हो गया. 0885DF यहाँ पे अलग, लेकिन अलग है. Here we have something different. Boot sector name कुछ नहीं है. Level USB1 that I have given. File system type is FAT32. Next free sector is this one, and free sector count is this one. So now you can see these informations are extra. ये FAT 16 पे नहीं था. If you have noticed, ये just ऊपर ही है देखो. तो यहाँ पे जब था क्या है, कितने free sectors हैं. In FAT32 they have added this information. This extra information was added into FAT32 file system. So they have added this free system, free sector. Next free sector कहाँ है और free sector count क्या है. And this you can think of कि ये use हो सकता है किसमें, जब हम लोग कल डिस्कस किया था ना कि allocation strategy क्या होगा. तो next available जो होगा, so we know that next available is this one, so we can start our search from that place. Whereas in FAT 16 we do not have any information, so we have to always start from the beginning itself, isn't it? क्योंकि कोई structure नहीं था उसके पास. I hope.
Yes sir.
Yes.
Sectors before file system. So now you can understand कि same disk पे है, same एक ही disk use हुआ है और उस disk पे ये दो partitions हैं. तो पहला partition अगर याद करो तो देखो पहला partition कहाँ तक गया है. First partition was this one, no? यहाँ तक गया है 6863. So next one we will start from this area 3876992. यहाँ देखो 38 यहाँ तक, ये 3876863 तक लास्ट क्लस्टर एरिया गया था इस सेक्टर तक. उसके बाद कुछ सेक्टर्स फिर तुम्हारा होंगे इसके लिए. सेक्टर एरिया स्टार्ट होगा वो इस एरिया से स्टार्ट होगा. So initial part has to be skipped again. Total range, it is saying that starting from 0 to this, total range is this one. So in fact if you recall कि ये इसका 0 जो है, this 0 is this number. Reserved is again 0 to 255. Now here the total number of reserved sectors are too many. Here you see that reserved was only 5 sectors were reserved. Here we have 204 sector, 205 sectors. In fact 0 to 205 means 206 sectors are reserved. Again the boot sector is in 0th as before. File system there is in 1, and there is a backup boot sector. Here देखो, this is something again unique and new in FAT32 which was not there in FAT16. FAT16 there was no backup boot sector, but in FAT32 we have a backup boot sector. Even in NTFS also we have a backup boot sector. So what this backup boot sector does, in backup boot sector whatever information is there in the boot sector, that information is copied in backup boot sector, and और वो उस तरह से एक copy है जो intact है. Now you are writing something and you suddenly take your pen drive out, or suddenly power goes on and so on. So sometimes that writing will be interrupted and your boot sector information will become lost, or sometimes it will become no. हो सकता है लिख रहे थे खींच लिए और गड़बड़ हो गया सर. Then this backup boot sector, whenever you insert the disk again in new system, it tries to compare the information which is there in backup boot sector and the boot sector. And if there is any differences in the backup boot sector and the real boot sector, the system start giving you a message that the file system is inconsistent. You need to check your file. You need to check your file system and so and so. So जो कल जो बता रहे थे ना कि कुछ informations जो आते हैं inconsistency का, so that is in FAT32 and NTFS, that is one of the reason कि यहाँ से वो check करता है. हर बार जब insert करते हैं तो it just compares the backup boot sector and boot sector, and then if they are different, we give the message that the files. But you know that even without that, most of the time you are able to use that. But if somehow the boot sector is totally say damaged, then there is no way. You have to either reformat the disk, or you have to basically check for the consistency and repair the disk. And while repairing the disk, repairing the file system, not disk, repairing the file system, what it can do, it will just copy the information from backup boot sector to your real boot sector, and then your disk will be again usable. Good. So
Yes,
that's
sir.
a good addition.
Yes, sir.
Again, here you can see there are two FAT. One FAT goes from 206 to 4198. The other goes from 4199 to 81. Again, the FAT is same what we discussed in the last one. We have a data area starting from this to this, cluster area starting from this to this, and then root directory. Now you can see the root directory again here at the beginning of the data area, but it is not necessary. In some cases, you will find out that in FAT32, this root directory may start in between this whole area, this data area. इस area के किसी भी जगह से start हो सकता है. लेकिन in FAT16, this will always come at the start. ये हमेशा ही root area जो है वो data area के start वाला ही कुछ portion होगा. But in FAT32, we have a liberty. It can come at a later space also. Right. Metadata, the range is this. Root directory is 2. Sector size this. Size is lesser. In fact, 4096. Size. छोटे क्लस्टर्स यहाँ बने हैं. वहाँ इनफैक्ट क्लस्टर काफी बड़े बड़े थे. सो टोटल क्लस्टर यहाँ पे 8 सेक्टर्स के ही क्लस्टर है. The clusters are only of 8 sizes. Total cluster range are this much, and in fact there was no such file. These are all system generated root and directory parent directory files. There is nothing. In fact इस file system में मैंने कुछ नहीं लिखे हैं, but फिर भी जो information आ रहा है, this information is automatically it has created the root directory, and root directory के लिए कहाँ से कहाँ, जैसे एक root directory क्या होता है, dot, और current directory होता है dot, and root directory is double dot. So for those information, it has kept all these things. So you can do a similar analysis. You can put some file and you can then check for it exactly file how this files goes on and so. So let's see. Let's go to one example uses now. Again, I'm going to use remote command to see you. That minus F SSTP1 ST slash SSTP1. So क्या हुआ सुनील जी? प्रेजेंट है, क्लास ले रहे हैं, तो देर बाद है ये. So this is one directory structure. Here, name, let me just. So it should give the name. Not why it is not name. It should give the name. Okay. So now see that if I just want to see a file and how it is. So this is about folder. You can see the name is demo folder 1. If you have, just let me show you. PWD current directory is home Jyoti. We have to change to that one. No? So let me just show you. If you recall, I hope another directory. So this is 10th one. This is another one. And 11, 3, 12. So let us just concentrate on this one. So I want, if you have noticed that there was a folder entry. So there was demo folder 1. Okay, and inside demo folder 1 we have several files. So demo folder 1, how the information of demo folder 1 is stored, you can see here. So if I give this sudo istat in statistics of inode or file information from fat, so this in practice, not in this way. This is, sorry, now it is. So if we give that, you can see it is directory entry 8. So that fat entry, what I was just showing you, is तरह का fat entry होगा, and then there will be a directory, and then directory will be allocated. When it is allocated, अगर इसमें, if in this one, if in this one, if it is 0, that means this is not allocated. If it is 1, that means it is allocated. So in file system, in fat information, if information about something is here, so information about this is 0, then that is not allocated. Otherwise, it is allocated. So some information will be there. Either it will be EOF or it will be some number. So except 0, if it is not 0, then it is allocated. So there won't be 0, so it is allocated. It is 3, size is this much, and the name is this one. Now this directory has 3 fields. So we talked about metadata. So far we were concentrating on the content. Now considering the metadata. So you can now see that there are 3 metadata. This is written, accessed, and created. So at what time this directory was written? So this directory was written at this particular time. It was last accessed at this particular time, and it was created at this particular time. And these are the sectors which are used for this directory. You can see here. Okay, so this is how we can think of, you might have similarly seen here that while I was trying, so with 10 as number 10, you have this attributes directory which was there in this and directory है. इस directory के बारे में अगर देखना चाहें, so this is what we have. So this is stored in these sectors.
Sir, directory means sir cluster.
नॉट क्लस्टर, डायरेक्टरी हमारे ऑपरेटिंग सिस्टम में जो हम फाइल्स पे ये ड्राइव पे डायरेक्टरी बनाते हैं ना, जैसे ये हमारा फाइल है, ये मान लो कि मेरा ये है, So even a directory is also a file. Everything is in operating system, everything is a file. Only the attributes change. सबको रखने का तरीका एक ही है, चाहे वो डिवाइस हो, चाहे वो फाइल हो, चाहे वो फोल्डर हो, उसके एट्रीब्यूट्स चेंज होते हैं, दैट्स ऑल. Got it?
Yes, sir.
So
Sir, how can we know about the director number?
that I was also not very clear about that. I will go through, and next week surely I will give you much detail about that. I was unable to find that information. That I tried.
We will also do that.
Hmm?
We will also go through about that.
I tried in this books to find out in so many places, but I could not find that exactly how that number and all those things they are taking. But by brute force searching, you can say by just randomly searching 2, 4,
Yes,
3,
sir.
5, I got something. But that's obviously not a very good idea. I will surely find out exactly how these numbers are associated with directory and from where these numbers are coming.
Okay,
I will
okay,
fully
sir.
explain to you. Okay.
Yes, sir. Yes, sir.
So today we'll stop here. Next day we'll continue with this FAT and then NTFS system. NTFS system, exactly what if we have NTFS, then how things will change, and then following that we will go through at least EX2, EX3 and EX4, EXT, sorry, EXT 2, 3 and 4. Regarding your midterms, just go through this book. Now the question what I will give you, know that I am not going to give you, that's for sure, that I think you should have an idea कि ये तो क्वेश्चन पूछने वाले नहीं है तुमसे कि एक्सप्लेन दिस और व्हाट इज दिस और व्हाट इज दैट. ओके, सो बाय दिस टाइम you should be able to assume क्या क्वेश्चन आएगा. So I'm just giving you certain hints. So what I can give you say this sort of informations. जैसे मान लो I may give this information say to you, and then I may ask you, you just draw the total file system structure on your paper. कैसे ये दिखता है, कहाँ से क्या हो रहा है, कितने क्लस्टर्स हैं, या अगर एक फाइल इस जगह से इस जगह स्टोर है तो उसका टोटल साइज कितना है, क्या है. That sort of simple calculations will be there. Then something of this nature, I can give you some sort of say this information like 0 to 200 in hexadecimal. This is basically 512. In fact, around 512. No, not 512, but 448 or something like that. So this sort of information I may give you, and then I may ask you ki exactly you determine ki how many partitions are there and what type of partitions are there in the disk, and so on. Good?
Yes, sir.
So that's for sure. The questions will be of that nature only. So I will give you certain numbers like this. So I will say probably I will take this snapshot, I will put it in the question paper, and then from there I can ask you some questions like say what is how many partitions are there, how many extended partitions are there, what is the nature of extended partition, from where this partition go. You draw diagrammatically, you show me this different whole disk is partitioned into that. Got it?
Yes, sir.
Yes, sir.
Then in the next one I can give another say boot 0, like here we discussed about this, no? You say boot 0, say boot sector 0 is basically the sector information from this one. Then I can take another snapshot of say boot 0, that sector number, that boot sector of that partition, and then again give you exactly if this is the boot sector of this one, what you have drawn earlier, then how many files are there, or how many things are there, and what other informations you can say figure out from that. What can be total slack spaces in this whole disk. So this sort of calculations I would expect from you in your midterm process. So you have enough time, try to prepare. So whatever I have discussed, so you try to make certain drive by your own and try to write it on your copy कि exactly अगर ये यहाँ से यहाँ है तो कितना होना चाहिए, कितना स्पेस जा रहा है, क्या हो रहा है. उसको प्रैक्टिस करो थोड़ा, ठीक है?
Yes, sir.
Yes, sir.
Yes, sir.
Okay then, for today. See you tomorrow in the lab classes. So in lab class again, I think class